Hi, I'm Jez Back and welcome back to the Cloud Chronicles. With me today, I have a wonderful guest from Gigamon. His name is Mark Jow and he is the EMEA Field CTO and Evangelist for the business. Hi, Mark. Welcome. How are you doing?
Great, thanks, Jez. Very well, thank you. And again, appreciate the time to spend with you today.
No, great. It's wonderful to have you on. So we're going to talk a bit about security today, especially cloud security, which I think there's a bit of explainer that needs to happen here because a lot of people have made some pretty wild assumptions that security in data centers was the same as security in cloud. I think we all can accept that's moved on, but I think so there's some nuance there. But also, last year was the first year when cloud cost management became a bigger priority than security in cloud since forever.
Yeah.
So I think it's worth going a bit back to basics. What are the big challenges around cloud security? And maybe a bit of explain about the differences between encryption, both in a old school and new school sort of environment.
Okay, great, thanks, Jez. So, I think firstly is if we look at the old world of on-prem data centers and infrastructures, a lot of the focus and discipline around security was very much examining traffic, network traffic, which moved north and south with firewalls, increasingly people putting things like microsegmentation strategies in place. And as organizations have migrated workloads and built new workloads, new cloud native workloads in public and private cloud environments, I think what we've seen is people following that same examining north-south traffic approach without really fully appreciating that in those cloud environments, it's really important not just to be able to see and get insight into traffic moving that might present threats north-south, but also to look at the movements that are happening laterally in terms of east-west. And so what we see is an increasing amount of attacks being centered at customers who are putting workloads into public cloud. Public cloud is becoming an increasingly hostile area for bad actors where they can attack organizations. And in many cases, those attacks are succeeding because those organizations aren't treating the east-west traffic, the lateral movement that's prevalent in those environments, seriously and inspecting the network traffic at that level, which is a big vulnerability. If you also add to that the fact that from a security perspective, and when we talk about encryption, clearly we're seeing now 95% of all traffic moving around internet access has been encrypted. It's a technology which was designed to keep us secure and safe, but in reality, that's now being used as a weapon against us by bad actors because guess what? They're masking their attacks in that very same encrypted traffic that's moving around hybrid cloud infrastructures. And either that's traffic which has been encrypted within a cloud environment, so at rest and moving around that environment, or traffic which is transiting through it because it's encrypted traffic from the internet, much of which needs to be examined to establish whether there's an external threat.
So just to pause there, when we talk about bad actors and using that same technology, what techniques, what things should organizations be considering, looking out for, from your perspectives, how they can be better? Because the whole point is, how can we do things better or do better things, right?
Yeah, exactly. And I think from our perspective, to do things better is make sure that you have solutions in place to help you identify, capture, and direct every single piece of network traffic that enters a on-prem environment, a hybrid and public cloud environment, and being able to access that traffic, to be able to direct that in the appropriate way to the tools that organizations have already invested significant dollars in implementing to keep them safe. And they could be NDR tools, they can be EDR tools, particularly SIM tools around helping with their security posture. And ensure that attacks which, for example, use techniques like command and control, where an organization or a bad actor might use, for example, a phishing link for someone to click on, they'll gain access through credentials to a weak part of the environment. They'll potentially dwell there for not hours, not days, sometimes months or even years, looking around that organization laterally, moving laterally to look for weak points. They'll identify weak points, and in reality, without the ability to look at the network traffic that's moving, they're able, and many people don't realize this, to fool the existing security tools in terms of masking their effort. And what they do that is a lot of security tools today use metrics, events, log files usually, but very few people realize that log files are actually mutable. They can be changed. So these actors are identifying the log files, they're copying them, they're manipulating them to mask an attack when they launch it. They'll then overplay the logs over the tools. The tools will think nothing's happening.
And make themselves part of the furniture.
Exactly, nothing to see here. They'll exfiltrate the data. The next thing that the customer sees is their data being offered for ransom on a dark website, or they're basically selling it for access. And that's all because, firstly, those organizations haven't got that network level visibility. And also, where that network traffic is encrypted, they don't have a cost-effective and resource-effective way in cloud of getting access to that encrypted traffic in the clear, which is a really important thing to now start to do. So I guess organizations that have that capability stand a better chance of resisting those common attacks that people are launching into cloud environments.
And are you seeing an increase in the proliferation of tools and also the data that goes with it, the data collection that goes with it, as part of this whole world of cloud encryption? And as we're transiting larger and larger amounts of data in an encrypted state, is that causing a cost problem for your clients that you're seeing, or is this causing a technology sprawl and complexity problem, tool proliferation problem?
I think the short answer is yes to both, and let me try and unpack that. So firstly, in terms of tool proliferation and the number of different cloud environments that customers are now, often for good reason, selecting for their environments. We've got many of our large enterprise customers with big on-prem environments, private cloud. They may have VMware and or OpenStack, some of whom are using Azure, AWS, GCP. Quite often, because of the pace to innovate and digitally transform and the power that the cloud development organizations are given, the focus is on build it quickly, build it fast, make it agile, just get it done. And what happens is often organizations select different tools for those different platforms when you boil it back to do exactly the same thing. So they might have different NDR tools on different cloud environments, a different one on their central location, where in actual fact they could standardize on one tool because they've just done it as they've gone along. It's like in the old data center world of stovepipe systems rather than, consolidated and intelligent tool choice. So that drives cost up because you have multiple different products doing the same thing in different places, more skills, more cost, more licensing, potentially even more hardware. That's the first thing. Secondly, quite often, even organizations that have rationalized the tools that they're using for things like NDR or SIM tools in those hybrid cloud environments don't really appreciate that they're sending far too much of the traffic and the data that they need to send to those tools for those tools to be fully effective. So the answer from most tools vendors will be, well, just create another copy, create another instance, put another VM up to deal with that volume. When you pare it back, not all tools need all data and all traffic. And so organizations are able to reduce the number of instances they need of all these tools by taking an intelligent view of which workloads do I need to send to these tools that are potentially high risk. If you're a university, for example, and most universities, probably 50% of their network traffic is Facebook, Twitter, Instagram, YouTube. They're low risk, there's no threat to those traffic streams, but yet they're still sending those traffic streams to tools, which burdens the tool with CPU time. It's got to filter that data out, and it's stopping it finding the things that are real threats from those workloads that might have threats within them. So what happens if you could filter out the application profiles and just send the threat application profiles to the tools that need it and throw that traffic away from an inspection point of view? Drilling down within that is, even within the traffic that is potentially high risk from the application profiles that you want to examine, in many cases, particularly with SIM tools, you don't need to see every single element of an entire packet or flow. You'll want to see specific metadata attributes that would identify a threat. And solutions that help you select that individual metadata specific to the threat types also massively reduce the volume of traffic you're sending to those tools. Quite often, Some solutions can get the volume of traffic down from 100% of the network traffic to as little as 5% of the traffic flow to that tool. That reduces network costs. It reduces the amount of CPU time you need for the tool and the copies of that tool as well. The final thing I would add to that is, in a public cloud environment where organizations want to get cost benefits and ideally centralize their tooling, because of the high egress costs of getting tool data back from public cloud environments, what organizations have had to do is they've had to compromise and actually ended up with distributed tooling, such that they have to keep the tools and the systems that look at the data for the threats within each of the individual cloud environments, rather than sharing that data back into a central location, because the costs of sending that data back will be prohibitive because of the egress costs for the cloud provider. If you're able to filter that data that comes back out of the public cloud to a central location, reduce that volume of traffic, but without compromising the fidelity of the information a central tooling infrastructure needs, then you can deliver a central tooling solution and not have the high egress costs from all these different cloud environments, which is a more efficient way of driving cost out of the business.
Some of the CSPs are now cutting their egress costs because that's where they're retaining customers better.
Exactly.
But the point still remains, irrespective of the egress cost, there's still a significant compute process crunch cost that goes with that, right? So that's important. Speaking of high compute and crunch, let's move on to generative AI, because that's a flavor of the month that people are getting very excited about. My perspective on generative AI is it's rather like the early adoption of cloud computing way back when, where everyone's getting super excited about it, but no one's considering the cost implications of it.
Yeah.
But from a security implication, and avoiding the whole deep fake and stuff like that,
Yeah.
where do you see the challenges around encrypted traffic being processed by AI with biases and all of that sort of stuff, and then coming back? Is there a risk of distorted patterns coming from that? What's your take?
Yeah, I think there is, and again, what I would say is I don't think it's in anyone's interest to stop organisations and individuals in organisations benefiting from the undoubted benefits of using that technology. But again, we're about helping organisations actually understand in detail where those tools are being used and accessed, and what information is being provided to those tools from where and to where, so they're able to get deep insight into what information is being shared or could be being shared externally with those tools, and how many and where are those tools, and how frequently have they been used and accessed. And having the data and the insight around the actual IP network traffic that's going in and out of the organisations to those recognised AI applications and tools is an essential set of data to be able to capture, to be able to refine, and be able to share with the tools that can come up with those risks for the organisations. But again, you're not able to understand how you're using AI, what data you're sharing with it, and when you're using it, unless you have access to the network traffic that's flowing between your organisation and those different AI technologies and platforms.
Great, thank you. So as we come to an end, as part of the Cloud Chronicles journey, I always like to try and add a bit of value for everybody. For you, what do you think are the big three things that people and organizations should consider now in terms of cloud?
I think the first thing is to stop assuming that from a security and visibility, network visibility perspective, that the cloud providers have them covered as part of their base solution. The fallacies around around what the cloud providers will and won't do are still prevalent, and you only have to look at that shared responsibility model to understand who's responsible for what, to realise that it's absolutely in their interest, if they're going to continue to put more data and workloads into public cloud, they have to take the ability to scrutinise and to direct traffic that's moving east to west, and to be able to see inside that encrypted traffic a lot more seriously than they are today, and stop continuing to accept the risk of encrypted traffic in the hope that they may well get away with it, because some of the breaches that we've seen in recent times suggest that that's not going to be the case. That's the first thing. I think the other thing I'd encourage them to do as well is to start to balance the pace of innovation and migration of workloads into cloud and the building of new cloud native applications, and start to think more in a more structured and forward-thinking way about what some of the downstream costs and risks and implications might be in rushing to build a quick workload in a cloud too quickly, without considering, could it be done more cost effectively somewhere else? Is there another tool that we have in our organisation that could avoid us having to spend yet more money on another tool, another platform for this environment, and start to think more long term rather than what they do today, which is innovate. It's all about innovation and agility. Let's feed that machine, and then let's not worry too much about some of the security and some of the multiple tools that we bought over that time. So, and again, if they don't start to do that, then effectively they'll just end up with more and more and more tools, because there'll always be a good reason for buying another tool, because we need to do it quickly. That has to stop being an excuse. Speed cannot be the enemy of cost.
Great. The iron triangle: cheap, fast, or good.
Yeah, exactly.
Absolutely. Thanks very much, Mark. Thank you very much for your time. It's been a pleasure. Thank you very much for watching the Cloud Chronicles. We'll see you soon.